Hi viewers, this is Dr. Jana and you are watching video with me on machine learning. In the machine learning algorithm, specifically we are going for the simple linear regression and all the multiple linear regression. And in this video, we will be discussing about the simple linear regression. What exactly we want to do it here? We will be having some independent variable in the x-axis and some dependent variable in the y-axis. And we are having some data, maybe connecting to some data source, whatever things are there. So using this data, say for example we create a model and we want to train the model. Say for example we can take some 70% of the data as the training data and 30% of the data for testing data. For example, we see here, suppose I am going for a simple linear regression where I am going for a TV sales based on the advertisement. Fine. So now what I need to do, I am implementing using this Jupyter notebook, using this Python. In this Jupyter notebook you can clearly see, first of all I should understand the data, and I am going for this simple linear regression. For understanding the data, we need to use some libraries. So first I use the pandas library from this Python. So we can use it pip install pandas, and we can import pandas as pd, fine. So with this, by default panda will be there. If it is not there, then it will be installed and we can import this one also. Then what we do, we need to upload the data, or you have to use this data. Suppose my data source is tv marketing.csv, it is in the csv file. Then how do I read this data? Say there is a method called pd.read_csv. So it must be a csv file, pd.read_csv, and my file name is tvmarketing.csv, which I have already downloaded and kept it there in the same folder where I am using. Fine. So I told you that I am using this Jupyter notebook. In this Jupyter notebook already I kept this TV marketing. I'll show you where I kept it. So okay, anyway, if you want to see, you can see it here. So this is the machine learning I am using, where the TV marketing is there by default. Yeah, it will be there. So TV marketing.csv, you can see this is the file, already I put it there, right? So then what I do, the same thing I save it with a I think variable like advertising. That means advertising means this is the TV marketing.csv, this is loaded there. Okay, so pd.read_csv, the file name is TV marketing.csv. Remember, if it is not in the same folder, then you need to provide the path where you are keeping this file. Okay, suppose d like that, and the slash, by default it will backward slash, you convert to forward slash, right? So this I store to advertising. That means now onwards I will be dealing the advertising to get all the data. Now suppose I want to see the first 5 line of the data. So use this advertising dot head. So if you want 10 lines, just you type it 10 like that you do it here. For each time shift enter is there for running this program, or you can run it here also by selecting, you can run it here. So already I run it here. So by running it is coming, we are having the first 5 data lines. That is when it is 0, it is the number of TVs this one, and sales is this one, like that. Okay. Then if you go for the tail, means last I am going for the last 5, then you can see, because I am having 200 of data items, so 0 to 199, so 195 to 199, 5 number of items, TV and sales also I can see it here. Then suppose I want to get some advertising information. So regarding where because the variable I stored advertising, that is regarding the TV marketing.csv. Okay, then you type advertising.info, this method. Here you can see what are the details. We are having the data 0 is TV, and we are having 200, that is not null, there is no non-null data, and it is data type is floating point 64, because some point is decimally there. So in this way we are having 2 items are there, one is the TV and other is the sales. Okay, that means based on the thing how many sales will be there, right? Then suppose I want to describe all things, and you want to see the shape also, that is advertising shape. The 200 number of rows are there, 2 columns are there, right? Then suppose I want to describe this data set, whatever you are showing. So advertising.describe, this method I can use it here. So what is the count? It is 200, TV is 200, and sales is also 200. Why this is necessary? Because sometimes some value is missing. So in that case, instead of 200 it may be 198, 196, but here it is showing all are there. And what is the mean? this is the mean and this is the mean. You know how to calculate the mean, sum total by the number of items, then standard deviation, and what is the minimum, what is the maximum, and all the things it is here that you can see using this advertising.describe method. Then for visualization, because what is the data, first I have to see it in a plot, then we have two things. We can use the this is SNS, that is the cburn we can use, or we can use the matplotlib. Okay, so my matplotlib by default will be there. Let us use this cburn. So import cburn as SNS. Okay, so no need to install because by default it will be there with that. So import cburn space as SNS. Now using this SNS I want to visualize. So SNS dot pair plot for what? Now this advertising means what is my TV marketing dot CSV, that is stored in the advertisement, and X variable I am putting TV and Y variable I am putting the sales. You see all there in the single quotation. Then size is equal to 7 and aspect is 0.7, kind is scatter. So I want a scatter plot. Okay, then when I run, so how to run this? So enter, shift and enter, you do it here, and this graph is plotted like this. Okay, and the graph is plotted like this. You can clearly see it is a plotted, a scattered graph. Okay, now what you need to do, say from this, is it possible to predict something? Because first of all I have to make a linear, just means I have to convert to some just like a straight line, y is equal to mx plus c. So when it is there, then I will force all this data into a particular line. Maybe the line will appear here somewhere. Then if it is represented by a linear, simple linear line, then only I will be able to predict the future, right? Then how to do that one? For doing that one, because the equation for linear regression is equal to y is equal to c plus m1 x1 m2 x2, like that it is there. So y the response or the output, c is the intercept in the y-axis, m1 is the slope here, okay, or yes, is the first coefficient, and this is the coefficient of the nth features are there, right? Here how you map to our TV advertisement. So here y is the response, c is the intercept in the y-axis, and m1 is the slope or whatever the coefficients I am going to calculate. Then this x1 is the TV, because I am having only one TV. I am going to calculate the cells, right? Predict the cells. Now then you will be using sklearn for preparing the x. So see how do you define this x and y? So x is equal to advertising TV. From this advertising there are two columns, one is the TV and one is the sales. So I am writing x representing advertising in square braces under single quotation TV. So if you try to print the first 5 items, x dot head, you see all the 5 items it is coming. This is the number of TVs sold, right? Except you can see 200 comma. So because we are having 200 number of rows and column, and by default it is once, there is nothing to worry. So similarly, what about y? Y is equal to advertising sales. There it is TV, here it is sales. So similarly you can see the y here also. Then the next important thing is that we need to train the model. For training we need to split the data. So for example, suppose training data we want 70% and test we want 30%. For that what we need to do, we have to go for scikit-learn. So this you can go for the sklearn documents there, just to type it in any of the browser, then it will appear. From that you can how to go for that, and you can clearly see. So from this sklearn.model_selection, import train underscore test underscore split. So these are the things, 3 things will be done here. So first I imported that one, then I describe x underscore train, x underscore test, y train and y test, which is equal to this method I am calling train test split. Here x y train size is equal to 0.7 and random state is equal to 100. Okay, so this is the things I have given. These things I think it is not necessary for us. Then immediately what we do, we go for see what is the x train, what is the training data set. Okay, so x train, the first two I want to check it here. So we are having this thing 74, this one, all the things, whatever things this given there. Now how do we perform a linear regression on that one? So for performing a linear regression, again we have to use the scikit-learn or sklearn. So from sklearn dot linear underscore model, from sklearn dot linear underscore model, import this linear regression. Remember, so first I import this linear regression. Then another thing is that from sklearn dot linear model, the same thing, import linear regression, same thing is repeated here. Then this linear regression method I store it as LR. So LR is equal to linear regression method, And now whatever the scattered data points you have seen here, if you remember there, the scattered data was like this, but I want to fit it into a line. Fine. So for that, what I need to do, I have to use a command here, and my command I am using it here. If you check it here, yeah, I am writing, yeah, not here, I think 2021 somewhere I have done. So lr.fit, so fit the model using the lr.fit method. Lr.fit what? No, x train, y train. So x, whatever the train we are giving, that is the x axis, and y axis what I have the y train. That means this x axis the cells, and TV and cells already it is given. With the same training data, I want to fit it to a line. So using this method I have done these things, right? lr.fit x train and y train. Now after this, what we need to do, it is done now. Then there is a way of calculating the coefficient. What is the coefficient? I will tell you, because when you map into a straight line, y is equal to mx plus c, and here m is equal to something like that, it is coming 0.0464, and c is coming 6.989. So we have by default it is here. Otherwise, if you want to know how it can be done, I will show you here something like that. You can have it here. There is a formula. Using this formula also you can see, if I am using for calculating this alpha and beta like that, or this m1 m2, this m1 is this one and m2 this one. So you are having, because what is the x, the independent variable x, and what is y, the dependent variable what is going to predict it. So we can make a table. This is x, this is y, sum of x, sum of y, and x into y, sum of xy. So sum of xy minus sum of x and sum of y divided by n into summation of x square minus summation of x whole square. So this we calculate alpha. Okay, the alpha means this is the one coefficient, this is another coefficient also, like that we calculate. Okay, so after calculating, so the first what is alpha, that is the coefficient of x. Okay, that is the m1x. Okay, that is 0.39x, and this b or whatever things you are telling, so that is the another thing, that is 65.14, right? That means if you map that equation to this one, then it can be represented by a linear straight line, right? So this is the same thing we have done it here. Now, yeah, now it is done here. Now I am going to predict. How do you predict? So y underscore, so for the predict also I use it here, y underscore predict, which is equal to, I have to use that linear model, linear regression, lr dot predict. What is the data I am putting? X test data. So because out of 100% data, 70% data I use for training, and remaining 30% only I am using for testing. Those test data I am using for predicting. Okay, and it will predict a number of things. But what you have to do, instead of taking all the things, we take a particular data and we try to calculate the predict. Okay, so with this we will be able to predict x test is this one, and I think it has come, and y predict also it is unable to calculate here. Don't worry, it will come. So then what we will do, we can also calculate the root mean square error and also r square value. So for this, import matplotlib dot pyplot as plt, c is equal to this one, and figure plt dot figure plt plot. So what I am taking it here, see the intercept, and y underscore test color is equal to blue. Also these are the general things, and figure subtotal actual and predicted, that is the versus actual versus, and x level we are giving index, and y level I am giving the cells, right? So based on this it will be done, and you can see the plot here like this, x axis, y axis, you can see it here, and somewhat on the other things also we are putting in the font size, this, that, and all things. After that you can see also that output also it will come, there is nothing to worry. Then we, from this scikit-learn, we can also calculate the mean square error. So for that, what you need to do, from sklearn dot matrix, import mean squared error, see mean underscore squared underscore error, comma, and also r2 score and mean absolute error. So these are the things I want to calculate, and once you run it here, just shift and enter, so it will run. Then you calculate the MAC. After calculating the MAC, it is coming 7.97, something like that it is coming. And also we can calculate the r squared is equal to r2 underscore score. So y test and y predict, all this mean it will calculate. So then we print the mean squared error MAC, and also we print the r squared. So r square value we are getting something like this, and mean square error also it is getting like this, right? So all the things we got it there. then you can go for a plotting of this thing also. After plotting, just you click it here and shift enter. I am running it first time for you, so shift and enter. Yeah, you can see it here. Sorry, shift enter. Yeah, anyway, it is not showing it here. I think some error, but anyway the same thing it will be done here, right? So I hope you are able to find. Okay, let me close this one. Yes, cancel, and yeah, one more I can show you what is my planning. So here you can see you come out of all these things, then you can see a simple linear regression. It is not come. Yeah, simple linear regression, it is also, you can check it here, and if you run this one, it will be coming like this. Yeah, this has come, it has come. So because there are showing some error in this while predict, anyway this same output you can see it there. Okay, so I hope now you got some idea how to implement this simple linear regression and what are the things we need to calculate there. Okay, the thing is that independent variable x is given and we have to calculate y. So for that, the existing data we divided 70% as training and 30% testing, and with the training data we trained the model, and before that we have to create a model using the linear regression LR model. So that we have done. Then once a model is there, then we go for the apply the training, and after that we go for the testing, and if any modification we can also do. So I think you have understood the basic concept on this how to go for this linear regressions. Thank you for watching this video, and if you like this video, please do share with your friends. Also don't forget to subscribe. So your subscription is very valuable for us. Thank you for watching this video. Thank you.